it's Kaala, and today we're going to do another science experiment. Since it's October, I thought it would be fun to do something related to the fall season. And if you're following me on Instagram, you may have seen a poll to decide the next experiment. So based on your votes, we're going to be learning about density using pumpkins. So what is density? Density is mass per unit volume, but in simpler terms, what that means is that it is a measurement of how tightly packed the molecules are of a substance. So if something is really dense, that means that its molecules are really tightly packed together. But if something is a lower density and not as dense, then the molecules are not as tightly packed together. So we're going to illustrate this by first looking at 3 different liquids with 3 different densities. Let me show you what we're working with. So we have some water, which I just got from the tap, some corn syrup. If you were following along with the blood model, you may remember this corn syrup, and some vegetable oil. Both of these I got from Winco. So let's get started. So what we're going to do is make a density column. Basically, we're going to add all of the different liquids into a jar, and we're going to see how they separate among the jar. Because they're different densities, they will remain separate from each other in the jar and not mix. That's pretty cool, right? Let's get started. Let's start with the corn syrup. We're going to pour half a cup into the jar. Okay, so we've got half a cup of corn syrup, and we are going to dye it red using food coloring. Decided to keep with the fall vibes by making all of the colors fall themed. What do you think? Does that look like a nice red? And now we've got our water, which we are going to dye orange. 1 drop of red and 1 drop of yellow. Half cup of vegetable oil. You see the separation there? So because these have different densities, we are able to see the different colors here. First observation, corn syrup hangs out at the bottom, the water hangs out in the middle, and the vegetable oil is floating on the top. So something that we can gather from this is that these liquids, of course, have different densities, which is why they remain separate in this container. Corn syrup seems to be the heaviest, the most dense. It was definitely the thickest liquid to pour, but it's also staying here at the bottom. So my guess would be that the corn syrup is the most dense, and the vegetable oil is the least dense. I looked up the densities of these liquids, and the density of corn syrup is 1.4 grams per milliliter. The density of water is 1 gram per milliliter, and the density of vegetable oil is 0.9 grams per milliliter. So that makes sense with what we're seeing in this jar here. The least dense is on the top, and the most dense is on the bottom. So let's look into this a little bit further. What's the density of a pumpkin? Well, that's a tricky question to answer because each of the different parts of the pumpkin have different densities, seemingly. So to test this out, we're going to be using a pumpkin. This one right here. We're going to look at the guts, the seeds, the rind, and the stem of the pumpkin to see if there's a difference between all of the different parts of the pumpkin and where they end up in our density column. All right, let's carve this. Success. Okay, I got a small piece of the stem. So I'll set the stem piece aside. We want to look at the seeds, the guts, and the rind. There are a lot of seeds in this pumpkin. I hope we have enough guts. Just so you can have an idea of what I'm working with, like, this is all of the guts. Like, that's it. I mean, I guess our column is small enough where I don't need too much, but still, I would have liked a little more to work with. So we've got pumpkin guts, lots of pumpkin seeds. Look at all these seeds. Came from this tiny pumpkin. Can you believe it? So we've got the guts, the seeds, the stem, and we just need the rind. I'm going to cut a small piece of this. We've got our rind piece. See, we've got the fleshy part and the skin. So the way that we're going to measure the density of the different parts of a pumpkin is we have our density column, and we are going to push all of the different pieces down into the column and then see where they end up. Let's start with the rind. Push it all the way down. Seeds. And try to push them down. They're not really going down. Let's try some of the guts. I'm going to push that all the way down. And last but not least, stem. Push it all the way down. Give this a little bit of time and then we'll see where they all end up. I had some time to let the density column sit, and so let's take a look. Looks like we've got our rind is hanging out here in the water mostly. We've got our pumpkin guts blending in with the orange water here. It's floating in there. Right on the top, we've got our seeds and our stem. We can roughly estimate the densities of these different objects. Because the rind and the guts are kind of hanging out in the water, we can guess that the density of these parts of the pumpkin might be around 1 gram per milliliter. And because the seeds and the stem are hanging out and kind of floating at the top, they might be around 0.9 grams per milliliter, or maybe even less because they're right on the top of it. So they may be even less than that. Thank you for joining me for this. This was a really cool experiment. Thank you for everyone who voted on my Instagram. If you want to follow along with me on Instagram, you can find me at Kaala Platypus, or you could follow me on TikTok as well. If you have any ideas for any future experiments, please let me know in the comments below. If you did this experiment at home and you got different results from what I got, please let me know as well. I want to know, maybe different pumpkins could produce different results. So just to recap, density is the mass per unit volume. The corn syrup was the most dense, and the water was the middle, and vegetable oil was the least dense. When we carved the pumpkin, we could see that the rind and the guts hung out in the water, the seeds and the stem hung out in the vegetable oil and kind of floated on the top. So we can further extrapolate that those parts of the pumpkin could have similar densities to the water and the vegetable oil. I thought that was really cool, and I'm so glad that I had the chance to do that with you all. If you like this kind of content and you want to support me, I have my coffee channel, which I will link down below. The idea behind it is that you are buying me a cup of coffee. This channel is definitely fueled by caffeine and by a lot of heart and a love for science. So if you align with any of those things, I would love your support. At some point, I'll probably put more specific goals on there. That's one of the things I like about the platform, is in addition to just being a place where you can support the creator with either a one-time or a monthly coffee, you could also set up different goals, like if there was certain equipment that I wanted to get, or if there was an experiment that you all wanted me to do, but it's a little more expensive, I could basically crowdfund. I know that there's some other types of thing where I can set up a monthly membership, but I haven't looked into that too much, but maybe at some point that will be a thing. If you want to support me in that way, I would be so grateful, but it's absolutely optional. Thank you so much for joining me today. I am so glad that we had a chance to celebrate the fall season. If you like this video, please like, subscribe, and hit the alert so you can stay up to date on all things me, whether that be science, theater, music, or anything else I do, because I do too much. And remember, you can do science too. Happy fall! Bye!